Most AI tools operate in a vacuum. They answer a question, provide a response, and immediately lose the user's context. When the tab closes, the session data disappears. Today, we are building LifeOS-Agent. This is a persistent AI chief of staff designed to autonomously manage long-term life plans by maintaining context over time. This system tracks your financial health, runs what-if simulations for future scenarios, and writes to a permanent memory, so it remembers your specific goals months or years down the line. To follow this build, you need active accounts for Google Cloud and MongoDB Atlas, Node.js installed locally, and a Gemini API key. By the end of this tutorial, you will move past building simple RAG demos and deploy a system capable of independent planning and long-term persistence. We begin with the memory layer. Open your MongoDB Atlas dashboard and establish a new database environment to serve as the backend storage for the agent's history. Create 7 specific collections: users, goals, financial profiles, agent memory, monthly progress, recommendations, and simulations. To enable Gemini to interact with this data, we use the Model Context Protocol, or MCP. Configure your local environment variables to activate this bridge. This structured memory layer gives the AI a physical location to store facts. It ensures that the specific context of your life remains available between browser sessions. Shift to your local terminal to clone the backend repository. You will need to insert your Gemini API keys into the configuration file to initialize the reasoning engine. 5 specialized agents, planner, finance, simulation, memory, and recommendation, power the backend. They never interact with the front end directly. A central orchestrator routes all traffic. Prompts flow from the user to the orchestrator, down to the planner, and finally to memory for permanent storage. This delegation allows the AI to execute multi-step workflows autonomously, processing complex plans without requiring a new prompt for every individual action. For the user interface, install the Next.js dependencies and link your front end to the backend. When you launch the local server, you will see the glass morphism dashboard. At this stage, the chat window is active, but the recharts elements and progress bars are waiting for live data. To move into production, we deploy the stack to the cloud. The backend runs on Google Cloud Run, while the front end is hosted on Vercel. This setup will likely trigger a CORS restriction error. You must go into the Google Cloud settings and authorize your Vercel domain to allow the 2 environments to communicate. Moving the code from a local environment to the cloud transforms the project into a globally accessible application. Open the live application and set a baseline test goal, buying a 25 million rupee home in 3 years. The agent immediately identifies the missing data. It pauses to ask for income, tracks your daily expenses, and reviews total savings before generating a complete plan. Once you provide those details, the dashboard populates your affordability score and plots a precise savings trajectory over the 3-year window. We can test the dynamic replanning by introducing a new variable. Tell the system your annual salary has increased to 7 million rupees. The simulation agent recalculates the data. Notice how the trajectory on the chart steepens, pulling your final milestone closer to the present day. The system evaluates these options and redraws trajectories as an active strategic partner, adapting the visual roadmap to match your changing financial reality. To test the persistence of the system, completely close your browser to wipe all local session data. Reopen the application and ask a vague follow-up question, like, "How is my house goal looking?" The AI successfully retrieves the past conversation and your updated salary data directly from the MongoDB MCP server. It knows exactly which house you are referring to because the data was stored outside the local session. This architecture can be expanded by integrating live banking APIs for real-time tracking or connecting to WhatsApp for automated notification of upcoming milestones. By combining Gemini's reasoning with persistent data structures through MCP, you are building tools that maintain continuity across the long-term arc of a user.